Good morning, everyone. My name is Jafar Sadiq Ali. I'm working as a professor in the Department of Electrical Electronics Engineering of Sri Muthukumar Institute of Technology, Chennai. I'm handling subject IoT concept applications. And now we are in the fourth unit, and we are going to see the interfacing. What we are going to see in this video lecture. And what is interfacing? We all know that interfacing means there's a device in between two different modules, two different blocks. That's for interface. Interface is the process of connecting sensors, actuators, and communication modules to a microcontroller or an IoT device. Why it enables data exchange between the hardware components as well as software components and so on. It acts as a mainly bridge between the physical world and the digital world. And why do we have interfacing component? Why it is important? Because from the real world, physical parameters like temperatures, viscosity of the fluid, or pressure, and so on. Whatever the real world physical parameters, we need to collect the real time data from using sensors and controls external devices and actuators. We want to control some external devices automatically means we need the interfacing part, and it enables the communication between with the cloud platform also and mobile application also. From remote, if we want to access, not only monitor, if you want to control something means, then you need interfacing part. So examples: temperature sensor, Arduino is a microcontroller, and cloud is a dashboard through which you can able to monitor as well as control. Okay, this is the interfacing. So we have seen what is interfacing and why it is interfacing is very important. The components involved in this IoT interfacing is nothing but sensors. These are sensors that act as an input device. Input device is sensors, and output device is actuators. What is actuators and what is sensors? These are opposite to each other. Sensor means it gets the physical parameters as input and generates an electrical signal, whereas actuators in getting the electrical signal as input and giving the physical movement, either mechanical movement or glowing buzzer sound, or glowing of a LED light, or operating a relay through the servo motor or whatever it is. It's called actuators. So these are the main two components: sensors as well as actuators. Input devices as well as output devices are the main component involved in the IoT interfacing. In between that, we have the brain called controller. It can be either ESP32 or Raspberry Pi 0, 1, 2, 3, 4 versions, and Arduino. Also Arduino. So here we have Arduino, Arduino Mega, Arduino Tiny, whatever controller you're able to use it, can use it. So these are the main three components of IoT interfacing, and also communication modules, as we said, Wi-Fi module, Bluetooth module, and low range modules also. And next we go to the types of interfacing in an IoT environment. So what are types are there? Hardware interfacing are there, as well as software interfacing are there. What is hardware interfacing and what is software interfacing? We will see that one by one. Hardware interfacing is nothing but connecting physical devices to the controller, physically connecting the physical parameters to the controller by means of sensors or some relays. This is the hardware part, or some LED connected to the GPIO pin. So these are the hardware things. What is hardware interfacing? Communication between devices using protocols, communication protocols, and also some software libraries. So these are the communication protocols is a very very important role playing in establishing the in connection between the two devices, either through wired protocol or wireless protocol also. Examples MQTT communication, which is a very low cost, frequently used, predominantly used in the IoT deployment. MQTT protocol communications and the cloud integrations. We can merge our IoT device into the cloud and mobile application connectivity. So these are the main two types of interfacing of IoT in IoT. We move on to next slide. Interfacing methods and protocols. So wired interfacing protocols. As I said, two things are the wired as well as wireless interfacing protocols. Wired, you have three main types: UART, Universal Asynchronous Receiver Transmitter. It uses transmitter as well as receiver pins of the microcontroller to connect with the external device. And it's a very simple serial communications. If you want to connect a microcontroller to a CPU, means obviously you need this type of battery. That's a USB connector. UART, Universal Asynchronous Receiver Transmitter. The second thing is I2C, Inter-Integrated Circuit. It uses SDA lines as well as SCL lines. SDA stand data acknowledgement lines and control lines. Synchronous data acknowledgement lines and synchronous control lines. SDA, SCL. It supports multiple devices on a single data bus itself. That's a peculiarity and is very very faster than the UART. The third one is SPI, Serial Peripheral Interface. It's a high-speed communication protocol commonly used with some display devices as well as memory devices. So these are the main three wired protocols for establishing interfacing. We'll move on to the next one. Now the second part is wireless communication protocols used in IoT. Wi-Fi, as we all know nowadays, Wi-Fi. Previous to Wi-Fi, we have been using it to the Bluetooth. Bluetooth, you know, for short range only. Between two mobiles, if you want to send data from file from one mobile to another mobile, obviously you go for Bluetooth only. Previous days, and Wi-Fi now we have very high-fi, very high-speed communication wireless protocol. We have its power consumption also ranges from medium to high power consumptions and generally used in smart homes, home automations, as well as the internet cameras also it's used. And Bluetooth, as we said, audio as well as wireless peripherals. If you want to, you are using nowadays, earbuds, that's a working in the Bluetooth classic model. And Bluetooth low energy BLE is a very low power version of Bluetooth. It is designed mainly for battery powered IoT devices for long life, health monitoring, fitness trackers, wearables, all those things you can find out this BLE. And Zigbee more wireless protocol. It's again a low power mesh networking protocol. It's mainly used in the home automation as well as wherever the smart lining concept has to be used, we can go for this Zigbee model. The first one is Z-Wave. Z-Wave also, it works in the sub gigahertz frequencies. It's mainly used in the smart lockers and home automations also. It's again low power. Everything is low power. And sixth one is LoRaWAN, long range wide area network. It's again obviously why we always say low power means because these are the things that has to work on a very minimal power using a battery and should come for a longer life. So obviously the cost should be one time cost only, installation will be one time only, and its usage is going to be a at least 5 to 10 years of time lifetime period. So that then how it's possible? Only by means of having a very low power consumption only. That's why in all the wireless things, a very low power consumption point is very essential. It's a working on the long range communication up to several kilometers also we can use it. And like basic Sigfox and NB narrow band IoT. Likewise, long term evolution for machines. Likewise, for this for fleet tracking, connected vehicles is the applications being used, and cellular networks as we know 2G, 3G, 4G, 5G, all this the cellular networks also we use this protocol, and RFID all everybody aware of it for inventory management as access tracking and near field communications also. So very short range communication, near field peripherals, contactless payments, contactless payments. Just go to the RFID. It's also contactless only, but it's a bulk amount. Smart cards also is used. And the third one is thread wireless HART dash 7. So likewise, there are many things are available for interfacing purposes. And next, we'll go to the one small example of interfacing in IoT environment. We have seen what is interfacing and why interface is very important. We have seen and we have seen the what are the methods and available for interfacing wired as well as wireless, both we have seen, and now we are going to see one class what are the main components also we have seen for interfacing sensors, actuators, microcontrollers, and now we are seeing the real-time experience of interfacing in IoT development. See that Arduino board is there and there are so many sensors are there, all are connected together. Some will get the input, sensor collect the data, controllers receive data through interfacing protocols as we have seen in the last two slides, and data is processed, analyzed, and communications module sends data to the cloud through IoT gateway is sent to the cloud, and user monitors data through a web or mobile application from anywhere in the world. And last one is commands are sent back to control actuators. Actuators means electrical signal will be converted into a some mechanical output. So this is the very classic example of how interfacing is being done in the IoT deployment. And our last and final slide is applications and advantages of interfacing in IoT. Applications everywhere: smart homes, smart agriculture, smart mobility, industrial automations, smart healthcare systems, and smart environmental and monitoring and surveillance systems. Everywhere it's been used, and main advantage, as we all know, that it reduces human intervention. The manual work has been drastically reduced, um, while and errors also have been prevented. Human error also have been prevented, and we are getting a real-time data collection, remote monitoring, and efficiency also improved. And since we done the automations, we are gone to the next level of human inventions. So with this, we concluded this interfacing of human IoT in IoT. Thank you so much.